Hi students, this is Alex here. In this video, they have given a rod 30 centimeter long has its end A and B kept at 20 degrees centigrade and 80 degrees centigrade respectively until steady state condition prevail. So we take a small diagram. We have a rod of length 30 centimeter and we have two ends A and B. One is kept at, that is A is kept at 20 degree centigrade and B is kept at 80 degree centigrade. The temperature at each end is suddenly reduced to 0. So they say the temperature is suddenly reduced to 0 and kept so. Find the resulting temperature function u of x comma t taking x equal to 0 at A. So we have a heat equation. Let's write that the heat equation is dou u by dou t equal to a square into alpha square into dou square u by dou x square. This is the heat equation. Since they have given, we have a steady state condition. In steady state condition, dou u by dou t is 0. So we can say that in steady state condition, the change in temperature with respect to time, that is dou u by dou t is 0. So using this dou u by dou t as 0 in our heat equation, we get alpha square into dou square u by dou square is 0 and hence dou square u by dou x square equal to 0. Then on integration of this, we get first a constant, then again integration constant into x plus another constant. So directly I am writing the solution. U equal to ax plus b is the solution of this equation. Now I got u and it is a function of x. So it is better if I write u of x. So we got u of x, which is ax plus b. Now when x is 0 at A, the temperature is 20 degree. So let's write here, when x equal to 0, u equal to 20 degree. So 20 equal to A into 0 plus B. So 20 equal to B. So I got the value of B now. In the same way, I am going to use the another condition, that is the other end. So the length is 30, so at B x is 30 and temperature is 80. When x equal to 30, we get u equal to 80. So if I substitute that in our solution, u of x is equal to ax plus b, we are going to get 80 equal to a into 30 plus 20. We can take 20 to the other side. So 80 minus 20 equal to a into 30. So this is 60 and 30 will come down as a division and that will be our a. So finally a is 2. So we got a and b. Now we get the solution u of x as ax plus b. We are going to replace a and b. So u of x is 2. Actually a is 2. So 2x plus 20. Now we are going to write the initial conditions. So let's write initial conditions. U of 0 comma t will be 0 for all t greater than or equal to 0. So they have given the temperature at each end is suddenly reduced to 0 and kept so. So we are having at x equal to 0, the temperature is 0. In the same way, u of another end is 30. So 30 comma t, that is also 0 for all t greater than or equal to 0. And third condition, which we got now, u of x comma 0 is 2x plus 20. So these are the initial and the boundary condition we have. Now I am going to take the suitable solution for our heat equation. So the suitable solution is u of x comma t is a cos px plus b sin px into e power minus alpha square p square t. Now I am going to use the first condition. Using the first condition, that is u of 0 comma t is 0. Wherever x is there, we have to substitute 0. By substituting, we get u of 0 comma t equal to a into cos 0 is 1 and sin 0 is 0. So we have only a now, and e power minus alpha square p square t, and u of 0 comma t is 0. So this is 0 equal to a into e power minus alpha square p square t. Here e power minus alpha square p square t is not equal to 0. Therefore a must be 0. When a is 0, our solution becomes, we are going to replace a as 0 here. So now u of x comma t will become, first part will be 0. We have only b sin px into e power minus alpha square p square t. We are going to use the second condition. So using second condition, u of 30 comma t is 0. So wherever x is there, we have to substitute 30. So now this is u of 30 comma t will be b sin p into 30 e power minus alpha square p square t, and this value is 0. So 0 equal to b sin p into 30 e power minus alpha square p square t. Now already a is 0, so b is not equal to 0 since a equal to 0. Similarly, e power minus alpha square p square t also not equal to 0. Therefore, the only option left is sin p of 30 must be 0. We have a basic formula. Whenever sin theta is 0, theta will be n pi. Here this is like theta. So theta, that is p into 30 equal to n pi. From this we got p, which is n pi by 30. So this n pi by 30 we are going to substitute in our solution. So u of x comma t will become now, b sin px n pi by 30x e power minus alpha square, p square is n square pi square by 30 square into t. Thus we got our general solution, which is u of x comma t, and we can write this as a summation from n is 1 to infinity bn, constant b is written as bn. We have sin n pi by 30x e power minus alpha square n square pi square by 30 square into t. Now we are going to use the third condition. Using the third condition, which is u of x comma 0 is 2x plus 20. So wherever t is there, we have to put 0, and this becomes u of x comma 0 becomes summation n is from 1 to infinity bn sin n pi x by 30, and e power 0 is 1. So we have left this much, and u of x comma 0 is 2x plus 20. So 2x plus 20 is summation n is equal to 1 to infinity. We have bn into sin n pi x by 30. Now this is the half range Fourier sine series. So this is half range Fourier sine series, and we can find the bn using the formula 2 by L integral 0 to L f of x sin n pi x by L dx, and f of x is 2x plus 20. So 2 by L, but L is 30 here. So 2 by 30 integral 0 to 30 2x plus 20 into sine n pi x by 30 into dx. Now we are going to use the Bernoulli's formula to integrate this. We take this as u and this as v. So u equal to 2x plus 20 and v is sine n pi x by 30. So sine n pi x by 30. So from this u dash is 2 and u double dash will be 0. And we want this integration is minus cos n pi x by 30 by n pi by 30, and v2 is minus sin n pi x by 30 by n pi by 30 whole square. Now Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 dot dot dot. And here in the constant bn we have outside 2 by 30. So bn equal to 2 by 30, then u which is 2x plus 20 into v1 which is minus cos n pi by 30 by n pi by 30, then minus u dash which is 2 and v2 is minus sin n pi by 30, even x will come here, by n pi by 30 whole square, and we have our limit from 0 to 30. Now we are going to apply the upper limit. So outside we have 1 by 15. After cancelling this 2 and 30, we have 1 by 15. When I apply the upper limit, so here when I put 30, we get cos n pi. And here when I put 30, 30 into 2, 60, 60 plus 20, 80. So 80 into, there is a minus sign, then cos n pi is minus 1 whole power n and whole divided by n pi by 30. This we can cancel, make it as plus. When I put 30 here, for this x, sin n pi, that will become 0. And when I put the lower limit, when I put 0 here, we left with only 20, and when I put 0 here, cos 0 is 1 and there is a minus sign, and divided by n pi by 30, and when I put 0 for this sign is totally 0. So we have only this much left, and sorry, this is 30. Now we are going to simplify this further. We have 1 by 15. This n pi by 30 I can take out. So n pi and 30 will go to the numerator. So like this I can take it out. And now we have 80 and 20. So this is minus 80 into minus 1 whole power n. Then this will become plus 20. And even I can take the 20 also common. So this we can cancel. It will become 2. So 2 by n pi, 20 is taken out common. After taking 20 common, this will become 1 and this will become minus 4. So I am writing the negative term as the second term. And this will become, finally, this is 40 by n pi and 1 minus 4 into minus 1 whole power n. This is the value of bn. And this we are going to substitute in our solution. That is, our solution u of x comma t equal to summation n is from 1 to infinity bn, which is 40 by n pi into 1 minus 4 into minus 1 whole power n, and sin n pi x by L e power minus alpha square and n square pi square by 30 square, which is 900 into t. And here we can take the constants outside the summation, so to give the final solution. So u of x comma t is 40 by pi is a constant which can be taken outside. Now summation n is from 1 to infinity. We have 1 by n. So let's write that first. 1 by n, then 1 minus 4 into minus 1 whole power n and sin n pi x by L. Actually, this L can be written as 30 because in our sum L is 30. So we can take 30 itself here. So this is sin n pi x by 30 and last term is e power minus alpha square n square pi square t by 900. This is the solution for the given problem.